Alright, let's check out the solutions to 6 through 10 on the MCA packet. Number 6, we're just evaluating an expression. And if you look at the possible solutions they give you, 2 of them are negative and 2 of them are positive. So one thing that could help you out here is to figure out, should I get a positive answer or should I get a negative answer? Because if you figure that out, you can eliminate 2 of your choices right away. So, looking at the top, or the numerator, I have a negative hanging outside of the parentheses there. So I know that the top is going to be negative, okay? No matter what, unless I end up multiplying by another negative up top, but there isn't one. So the top is going to be negative. And then the bottom, let's check and see what that's going to look like. If I end up dividing by a negative overall, then I will get a positive, since a negative divided by a negative will give me a positive. So what we need to check out is this right here. Will that negative go away? And it turns out that it will, because it's inside the parentheses, meaning that the 2, where the exponent, applies to this negative right here. So this really means negative 2 times negative 2, which gives me a positive 4. And then everything else is positive down there as well, so we find out that the bottom comes out positive. Well, when you divide a negative by a positive, you get a negative answer, so we can eliminate C and D. Alright, so let's check this out. This is how most of you would probably go about it. This doesn't mean this has to be the way that you do it, so if you do it a different way, that's fine. Just make sure you come up with the same answer. I know the top's going to be negative, so I'm going to take 2 to the 5th power. That means 2 times 2 times 2 times 2 times 2, which comes out to 32. And then 3 to the 3rd power, 3 times 3 times 3 is 27. We already talked about that. That comes out to positive 4. And then 6 to the 2nd is 36. So what you can do here is kind of do some simplifying. You could multiply the top together and then divide it by the bottom. That's an option. But if you don't have a calculator, I would recommend doing it this way. Split it up like so, and do some cancellation. So negative 32 divided by 4. Or if you want to reduce that, I can divide both of these by 4, and I get 8 over 1. And then here, I can divide each of these by 9. So this 27 becomes 3, and 36 becomes 4. Now if I multiply straight across, I get negative 24 up top all over 4, and negative 24 divided by 4 gives me negative 6. So we're looking at B for that answer. Alright, number 7. Real quick way to do this. They want the answer in scientific notation most likely, but let's check. I would reorder the way that we multiply this, so I'd put 4 times 7 together and 10 to the 5th times 10 to the 7th together. We can reorder the way we multiply due to the commutative property, so I get 28 times 10 to the 12th, because these have the same base. That means I can add my exponents, 5 plus 7. So I don't see 28 times 10 to the 12th. I see 2.8 times 10 to the 12th. But let's put this in scientific notation. My decimal points here, I'm going to move it between 2 and 8. However, this exponent right here tells me the decimal wants to go this way, and we are moving at one spot backwards. So I have to add 1 up here, so this is the same as 2.8 times 10 to the 13th. So we're looking at B there as well. Okay. Alright. Letter, did it again. Number 8, which of the following tables does not represent a function? Remember, functions do not have repeats in the domain, and the domain always talks about your x values. So we are looking for the chart that has repeats in the x values, and if we keep scrolling here, we find out that C happens to be the one that has repeats. This is not a function. Everything else is, okay? So if there are repeats in the domain, not a function. Alright, so that one's quick. Which of the following functions is not linear? Okay, we talked about this quite a bit too, and Remember, it's okay if you have a variable in the numerator, but when you have one in the denominator, that can be an issue because you can never divide by 0. So D happens to be the one that is not linear, okay? The rest of those could be put into slope-intercept form. That one cannot be. And lastly here, which sequence is arithmetic? That means we're looking for the one that's either adding by the same amount each time or subtracting by the same amount each time. So you can do a process of elimination. All of these have a pattern, but only one of them is arithmetic, and it happens to be B. To get from 12 to 7, you subtract 5. To get from 7 to 2, you subtract 5. To get from 2 to -3, you subtract 5. And from -3 to -8, you also subtract 5. So there we are subtracting, or you could say you're adding by -5 each time as well. So while the rest of those also have a pattern, B is the only one that is arithmetic. And that's all I've got for this section. So we'll move on to the next section next.